So let's start the class. Okay, hi guys, welcome to NEET World Institute and NEET World YouTube channel. So as you know that this series is particularly for EAPCET aspirant of 2026, right? So this is for both engineering stream and medical stream, and in this session we are going to concentrate on the physics chapter. Okay, as we have completed the system of particles in last class, and now we are going to start with gravitation in this class, right? So let us wait for 1 or 2 minutes, like the people are joining over here. Okay. Okay. So once it gets loaded, we'll start with the class. Right. So yes, we are going to start with the gravitation. Okay, the first topic which we are going to see is a Newton's law of gravitation, right? So every body in the universe attract every other bodies with the force which is directly proportional to, yes, proportional to masses of the bodies and inversely proportional to the square of the distance between them, right? So this is Newton's first law of gravitation. What he is saying is the force is directly proportional to the two masses m1 and m2 and inversely proportional to the square of distance between them, which means we can say that F is directly proportional to m1 m2 and inversely proportional to r square. So to remove the proportionality, we are adding a constant called g. So the g is nothing but gravitational constant. Okay, gravitational constant. So when I talk about a force which is exerted by m1 on m2 or else m2 on m1 will always be equal, right? So only the thing is it will be in opposite direction. So F1 is like force F1 on 2 will be this direction and 2 on 1 will be in this direction. So F12 will be equals to minus of F21, right? Why? Because minus, it is in opposite direction, right? So when I talk about in magnitude wise, both are equal forces, like equal and opposite forces, Okay. So, F is equals to g m1 m2 by r square, where g is called as gravitational constant, which is nothing but 6.67 into 10 power minus 11 Newton meter square per kg square. Okay. How we have got that Newton meter per kg square? Simple. When I talk about F is equals to g m1 m2 by r square, right? When I take only g on one side, remaining term other side, F r square by m1 m2. So, when I talk about the units, Newton meter square by kg square, that is why we have written Newton meter, yes, Newton meter per kg square. So, 6.67 into 10 power minus 11 is the unit, I mean the value of the gravitation constant. Okay. You can take a note of this and we will go for the next one. Done. Can we go for the next one? Yes, fine. So, Newton's gravitation law in vector form, how we will represent is F is equals to g m1 m2 by r square into r cap will represent. Okay. So, here gravitational force is attractive force. When I talk about the charges, no, like positive charge and negative charge will be there, which we are going to discuss in class 12th chapters, right. So, in that when I talk about minus q plus q, they will attract. When I talk about minus q and minus q or plus q and plus q, they will repel. So, when I talk about these two conditions, attraction and repulsion will take place, but whereas gravitational force is always attractive, always, okay, is always attractive. Okay. And from the Newton's third law, we have written that F12 will be equals to minus F21. Okay. When I talk about in magnitude wise, it will be only F. Okay. So, this is about in vector form, and attractive force is always attractive. They might ask the question, is gravitational forces attractive, repulsive, or both, or none of these above? So, what is the answer? Yes, it is attractive force. Okay. Yes. So, here are the some points about the gravitational force. Okay. Action and reaction pair. Okay. The force F12 and F21 form an action and reaction pair. Action pair and reaction pair, like F12 will be is equals to minus F21. Okay. Action and equal and opposite reaction. They are equal in magnitude but opposite in direction. Okay. Opposite in direction, when we are talking about vectors, we need to talk about the direction also, right. Vector has both magnitude and direction. Second point, independent of medium. Gravitational force does not depend on the medium between the objects. Okay. Example, whether the bodies are in air or water, the gravitational force between them remains same. Okay. And the distance between also same only. So, first point is action and reaction pair, and it is independent of medium. Third point, unaffected by other bodies. So, which is similar to the second point. The gravitational force between two objects is not affected by the nearby objects, even if the bodies are present between them. Okay. So, it is unaffected by the other bodies. So, Newton's shell theorem is the fourth point. For a body outside a uniform spherical body, no, all the masses of the sphere can be considered as a concentrated to its center. Okay. For a body inside a hollow sphere, the net gravitational force will be 0. So, when I talk about a body which is outside, it is considered as a, consider at the center. When I talk about inside, no, it will be 0. It will be 0. Okay. So, whereas for this body and this body, no, there will be a gravitational force. But when I talk about this body and this body, there won't be any gravitational force. Okay. That is shell theorem says. So, 4 points. Next we will see some more points. Okay. Fifth point, a force between non-spherical bodies. For irregular shaped bodies, we cannot talk all masses are concentrated at one point. When I talk about a spherical shell, no, like it's a shell will be concentrated at the center. When I talk about irregular shaped bodies, we cannot take all masses concentrated at one point. But if the distance between them is very large, compared to their size, we can approximately take as a point mass. Okay. If I consider this as a irregular body and this is a some point is there. If I want to find what is the gravitational force, I need to find what is the center point. Okay. Suppose the thing is this is irregular shape and somewhere too large, okay, the body is present. So, this body I can consider as a point mass. I can consider as a point mass. That is the point of the fifth one. Okay. Next one is universal nature of gravity. Okay. So, gravitational force acts everywhere in the universe. So, when we talk about first one, between the bodies on earth is weak. Second one, between earth and the moon, it controls motion, and between stars and galaxy controls texture and evaluation, and it becomes significant only when at least one body is very larger. Okay. So, fifth point and the sixth point. When we talk about the seventh point, conservative nature. So, gravitational force is in conservative force. Gravitational force is a conservative force, first point, and this means the work done by gravity depends only on the initial and final position. So, what is conservative force? It depends on initial and final position, not on the path has been travelled. Okay, path has been travelled. So, no work done is done in closed path. Okay, work done will not be in the closed path. Closed path work done will be 0. Okay, initial and final position, no. So, displacement will be there. When I talk about a closed point or closed path, displacement will be 0, whereas distance is there. Okay. This is about the seventh point, which is conservative forces. Done. Can we go for the next one? Okay. So, the next one is a reason for a spherical shape of a planet. Why? What is the reason? What is the reason behind the spherical shape of the earth or whatever it is, like a planets? What is the reason? Because due to mutual attraction between the particles, they move closer and body takes a spherical shape. Body takes a spherical shape. This effect is strong for larger bodies like a planet, stars, okay, and weak for smaller bodies like asteroids. So, that is why asteroids are like irregular shape. So, small ones are not spherical, small ones are spherical. Okay. So, the ninth point, Earth's attraction and your weight. So, Earth attracts every object, that is why you have weight. So what is the meaning of weight? It is mass into gravity, right? When I talk about mass, it is a scalar. When I talk about weight, it is a vector, because this weight having a direction towards down, right? So you also attract the earth with an equal force, but earth doesn't move because its mass is extremely large. Okay, only we move, like because of our mass is very low when we compare with earth, so its acceleration is negligible. Okay, so 10th point is, if a particle experiences a gravitational force from many bodies, each force acts independently, so the net gravitational will be, so if I take a body, like some n number of forces are acting, then what will be the force? F net will be equals to F1 plus F2 plus F3 up to Fn. So this is principle of superposition, we will say. Okay, we are adding the forces which are acting on a body. Okay, we are summing up the forces, so which is called as principle of superposition. Okay, you can take a note of this. Done? Okay. We'll go for the next one. Okay. So the next one is, the question. Okay. So we have completed one topic. So we'll see some questions. How to proceed with the questions, we will see. So 3 equal masses of m kg each are fixed at the vertices of an equilateral triangle ABC. Okay. So what is the force acting on mass 2m, which is placed at the center of the triangle, which is called as centroid? Okay. What is the force if the mass at vertex A is doubled? Vertex A is doubled. So this is the diagram. I need to find what is the force acting on this, right? Okay. Let's calculate. First question. Second question, if this mass become 2m, what will be the force? What will be the force? I need to calculate it. Okay. So let's take a diagram here. So this is my triangle, right? Where is the shape? Yes. So this is my equilateral triangle. So here is the mass m, here also the mass m, and here also the mass m. When I talk about the mass 2m, which is placed at the center of triangle, that is centroid, this is A, this is B, and this is C. I need to take the masses or the forces in the axis. Okay. So when I talk about this is exactly in y axis. When I talk about this is in the plane, I need to take in x axis and y axis. That's the thing. Okay. When I talk this, no. Yeah. So when I talk about this, so this angle is how much? So divided into 3 parts. So sum of angle will be, this total will be 360 degree, divide by 3 in the sense 120. Okay. 120 and this is 120. So 120, 120, 240, 240 plus 120, 360. So total 360s. Okay. So when I talk, this is my x axis and this is my minus x axis and this is my y axis, right. So when I see this x axis and this B, how much angle it has been made? Only this one I need to calculate. If this is 90, this will be 30 and this also will be 30 degree. Done? Yes, no? So when I talk this one is, yeah, it is in y axis only, and we will go for the question now. So when I talk this, AG is equals to BG is equal to CG. So the distance between them are 1, okay, 1 meter. So now force of AG will be equals to G into M into 2M by R square is 1 square, which is nothing but 2G M square by, sorry, M square, that is it, 2G M square, right. No, this is 1 square, okay, let me write this properly, 1 square. So that is the force. When I talk about this, no, like it has been, yeah, like components as should be taken here. So component in the sense, this is my cos and this is my sine, right. So cos, this is how much? So cos 30 degree and this is sine 30 degree. Cos 30 in minus x axis, so minus I cap, and this is minus j cap. When I talk about this, again here cos 30 degree plus, and again one more minus sine 30 degree j, okay. So when I take the component for C, cos 30 plus cos 30 minus sine 30, when I take the component for B, minus cos 30 minus sine 30, okay. So force BG will be equals to G M into 2M divided by 1 square into how much? 1 is minus cos 30 degree j I cap, no, I cap, again minus G M into 2M by 1 square sine 30 degree j cap, okay. So let me take here, this is cos 30 degree plus, now FCG will be equals to minus G M into 2M by 1 square, 1 is minus 30, okay, minus sine 30, okay, let me write this as positive cos 30, okay, first will be equals to positive cos 30 degree I cap, no, I should mention the axis, so this one will be j cap, positive j cap, okay, and minus G M into 2M by 1 square sine 30 degree j cap, okay. Now F net will be like force, what is the superposition principle is called, like sum of force will be equal to F net. So F net will be equals to F AG plus F BG plus F CG, right. No, got it, okay. Now what I should do now, I should add the things here. So let me take, this is 2G M square j cap, what is B? This is minus GM minus 2 GM square cos 30 I cap. So minus 2 GM square cos 30 I cap minus 2 GM square sin 30 j cap, right. So what else is left? CG is left. CG is plus 2G M square cos 30 I cap minus 2G M square sin 30 j cap. So is there anything common here? Yes, 2 gm square cos 30 I cap, but it is in negative, it is in positive. So cancel it. So remaining 2 gm square j cap. So minus and minus can be minus 4 gm square. Sin 30 is 1 by 2. So 1 by 2 j cap. So 1 times and this is 2 times. So final answer will be 2 gm square j cap minus 2 gm square j cap. So F net will be nothing but 0. So the force which is acting on the centroid, a force which is acting on the centroid of the triangle, like centroid of the triangle, is 0 when we keep masses are same at the vertex of the triangle. So this is the answer. Okay, this is how we will solve the questions when they are asking like this. Okay, so second part of the question is there, if this becomes 2m, what will be the force? Okay, so you can take a note of this and try to do second one, we will see. Done? Can we do the second part of the question? Okay, so second part of the equation we will do now. So let me take a triangle. Okay, now this is A, B and C. So this is my M and this is my M and this is my 2M. Now centroid how much? Now 2M, no? Now similar method, what I should do? I should take the components and I should simplify in x and y axis, right? So let me take that. Okay, so now when I see this, this is my 30 degree, again this is my 30 degree, no? Right. So this one will be I cap, I mean j cap, positive j cap, this is positive I cap, negative I cap, negative j cap. Okay. So angle which is close to the axis is cos. So this is minus cos 30 I cap for B and minus sin 30 j cap for B. Now for C how much it is? Plus cos 30 I cap, again minus sin 30 j cap, sin 30 j cap, right. So, these are the things. Now, force F AG will be equals to F AG, G into how much? One is 2m, other one also 2m only. So, 2m into 2m. So, in the previous case we have written m square, right? Yes, it is fine, m square only, correct. So, by 1 square, how much it is, j cap or I cap? It is j cap, positive j cap, okay, y axis, no. And when I talk about FB, no, FBG, both are minus. So, minus G 2m into 2m by 1 square. So, this is how much? 4G m square j cap minus, so this is cos, no, how much? Cos 30 degree I cap minus G into 2m into 2m by 1 square sin 30 degree j cap. So, let me simplify this. So, this is not 2m, right? Okay, wait a minute, 1 minute. So, this is my only m, okay, only m into 2m, okay, m into 2m, not 2m into m, okay, not 2m into 2m. So, it is minus 2g m square cos 30 degree I cap minus 2g m square sin 30 degree j cap, right. FCG will be equals to same, one will be positive, one will be negative. Which is positive? Cos. Which is negative? Sin. Okay. So, 2g m square cos 30 degree I cap, okay, minus 2g m square sin 30 degree j cap. Done. So, now F net will be equals to force of A on G plus force of B on G plus force of C on G, right. So, can you simplify this and give answer for this question? So, we have done almost, only the final step is there. Complete it first, we will see. Once you have completed, we can cross verify the answer. Okay. So, we have done, we can cross verify the answer right now. Okay. Now, I should add everything, right. So, adding in the sense, yeah. So, this is 4g m square j cap plus, and this minus, no, sorry, minus 2g m square cos 30 I cap minus 2g m square sin 30 j cap, and this is plus 2g m square plus 2g m square cos 30 I cap minus 2g m square sin 30 j cap. So, here minus 2g m square cos 30 I cap plus 2g m square cos 30 I cap can be cancelled out. So, the remaining will be 4g m square j cap minus 4g m square sin 30 j cap, right. What is sin 30? It is 1 by 2. So, 4g m square j cap minus 4 in g m square into 1 by 2 j cap. So 2 and 4 will get cancelled like 2 times, right? So it is 4 g m square j cap minus 2 g m square j cap. So both are j only, right? So final answer will be 2 g m square j cap. So it is in positive direction. So F net will be towards up. It will be towards up, right? It will be towards up. Yeah, I guess it's now clear. No, the board is clear now. Yes, it is towards up. So this is the answer for this question. 2 m square j cap. I should see the sign also. It is plus. Okay. Next we will go for the next topic, a spherical shell, that is Newton's shell theorem. Okay. A spherical shell means a hollow sphere. Okay, hollow sphere. Like sphere is there, like inside it is hollow. Okay, with a uniform mass distribution over its surface. Over its surface in the sense, this is my surface, right? Okay. So there are two cases depending on where the point mass is placed. Okay. So first one, it is outside the sphere, one is inside the sphere. So what will be the gravitational force and what will be the gravitational force? I need to check it. So the first case, point mass outside the spherical shell. Okay. So let us see only the formulas here. The formula is Fgm square by, say Fgm by r square, Fgmm by r square. Okay. When I talk about a point mass inside the spherical shell, F net will be 0. Okay, F net will be 0. Okay. So these are the two things which we need to note down in the spherical shell. Okay. So next one, a gravitational field or gravitational field strength. So what is the meaning of that field or field strength? Suppose we will see what is the gravitational field strength is. So every object that has a mass attract the other object towards it due to gravitational force, right? The space around an object where this force can be felt is called gravitational force. Suppose if I consider there is a system, okay, there is a system and here I have kept one object. If I want to experience the force, an object should be inside the system only. If I place an object here, can I experience something? No. If I place the object here, yes, I can experience the force, I can experience the gravitational field, right? So example, the space around the earth where we feel the weight of an object is gravitational field. So the earth pulls everything towards it. That's why things are fall down. Okay. The region around the earth where this pull act is called a gravitational field. So simple example we have taken and we have concluded that, right? So nature of the gravitational field we will see. So it is a vector field, meaning it has both magnitude and direction. Yes. So direction of the gravitational field is always towards the center. So when we talk about the direction, it will be towards down, towards the center. Okay. So gravitational field strength formula is, and which is denoted by E. Formula is F by m. So if I take a system, if I keep a point mass, then only I can experience as a force. So which means F is equals to G m capital M small m by r square divided by m, no, right? So E will be equals to F by m is nothing but G m by r square is the formula for the field strength, gravitational field strength. G m by r square, that's it. Okay. So where E is nothing but gravitational field strength and F is nothing but gravitational force and m is nothing but mass of the object. So what is the unit and dimension? So unit is Newton per kg. This is Newton and this is kg. So Newton per kg is the unit and dimension is m power 0, L power 1, T power minus 2. Okay. So this is the gravitational field strength concept, right? I hope it's clear. Okay. So with this we will end up the today's session, okay, and we will see the upcoming topic in the next class. Okay, thank you guys, we will meet in the next class. Bye bye.